All right, so today in Algebra 2, we're going to finish up section 5.1 notes. Okay, so we're going to pick up where we left off. Simplify nth roots. Okay, so yesterday we looked at only numbers underneath the radicals. Today we're going to look at when we have variables raised to an exponent. So the very first one says the fifth root of 32 and then m to the 15th. Again, remember that 32 I can do my factor tree on. Since it's the fifth root, I need 5 of them to come out. So 32 is 8 and 4, 8, 2 and 4, 4, 2 and 2, 4, 2 and 2. So again, I have 5 2's. And this will be one that we memorize because we will do it so many times. The fifth root of 32 is 2. Okay, so I know that this is 2. So now m to the 15th, okay? The fifth root of that, the easiest way to do this is to divide your exponent by your index, okay? So here my exponent is 15. 15 divided by 5 is 3, nothing left over. So since there's no remainder, there's nothing going to be left underneath my radical. So m to the, again, 15 divided by 5 is 3, so m cubed comes out. So 2m cubed. All right, so now we're going to look at number 2, the fourth root of x to the 20th, y to the 8th. Okay, I have to pay attention when I have an even root. Okay, so if I have an even root, remember we said that we could have 2 answers, positive and negative. Okay, so we're going to pay attention to that here in just a minute. So I'm going to go ahead and write all of this as the absolute value when I bring it out. So x to the 20th, the fourth root of that, 20 divided by 4 is 5. So absolute value of x to the 5th. Y to the 8th, 8 divided by 4 is 2, so y squared. Okay, the exponent x to the 5th, because it is an odd exponent, I could have a negative number, right? But the original problem had a fourth root. So original problem was, and it was raised to the 20th, which is even, so it must be positive. Y squared is always going to give me a positive sign. I'm never going to have a negative sign. So I don't need the absolute value for the y squared. So my answer is going to be absolute value of x to the 5th, y squared on the outside. Okay. Again, because x to the 5th, the exponent is odd, so I could have a negative number there, but the original exponent in the problem was raised to the 20th power, which means it has to be positive. Okay, so that's why I need the absolute value sign. Again, y squared doesn't need to be in the absolute value because y squared, it's always going to give me a positive number, right, when I square it. All right, so now let's look at number 3. So I have the cubed root. Okay, so again, my index is odd, so I don't have to worry about absolute values here. The cube root of negative 8, okay, so I know that's going to be a negative number, so the cube root of 8 is 2, but this was a negative 8, so this is going to be a negative 2. A to the 3rd, so 3 divided by 3 is 1, so just a. B to the 9th, 9 divided by 3 is 3, so b cubed. So there's my answer, negative 2ab cubed. Number 4, the fourth root, so I'm going to have to pay attention to, since I've got an even root here, I'm going to need absolute value. So I'm going to go ahead and put everything in absolute value to begin with. So the fourth root of 256, what one number can I multiply by itself 4 times to get 256? That's 4. X to the 12th, 12 divided by 4 is 3, so I get x cubed. Y to the 24th, 24 divided by 4, I get 6. Y to the 6th. So now let's talk about what has to stay underneath the absolute value sign. So this is equal to, I have a 4, well, it's a positive 4, so that can come out. X to the 3rd power, that's an odd exponent, but my original exponent was x to the 12th, which is even, so the x cubed has to stay in the absolute value sign. Y to the 6th is even, so no matter what, that would be positive. So there's our answer. 4 absolute value of x cubed times y to the 6th. Now we're going to look at using nth roots to solve equations. Okay? We're going to solve just like we always have. Our goal is to get the x all by itself. So number 1, 2x to the 5th equals 64. The very first thing I want to do is get rid of that 2. So I'm going to divide everything by 2. So then I get x to the 5th equals 32. Now I need to get rid of x to the fifth, so the opposite of raising something to the fifth power is taking the fifth root of it. So I'm going to get x equals the fifth root of 32. We already know how to solve that. And again, this is one we use a lot, so we hopefully have that memorized by now. X is equal to 2. You can always check my answers, right? So if I plug that back in and did 2 to the fifth power, I'd get 32. 32 times 2, 64. So we know that we're right. Number 2, 5x cubed equals 320. Again, the very first thing, divide everything by 5. So then I get x cubed equals, so 320 divided by 5 is 64. So now get rid of x cubed, so take the cube root of both sides. So I get x equals the cube root of 64. The cube root of 64 is equal to 4. So my answer, x equals 4. And again, I could plug it back in and check. All right, number 3. 2p to the fourth equals 162. Divide everything by 2. So I get p to the fourth equals 81. Get rid of being raised to the fourth power, so p is equal to the fourth root of 81. I put fourth root in, therefore 2 answers, right? Always be careful of that. And be mindful, if you put the radical in the problem, and it's an even root radical, then you're going to have 2 answers. So here, p is equal to positive and negative. Okay? What one number can I multiply by itself? 4 times 81? 3. So p equals positive negative 3. Right, and number 4, x plus 4 quantity cubed equals 27. So on this one, we have to start out by taking the cube root of both sides to begin with. So then I get x plus 4 equals the cube root of 27. So x plus 4 equals, well, the cube root of 27, that's 3. Subtract 4 from both sides, so x equals negative 1. There's our answer. Right, we're going to finish off today with 2 word problems. So the first one, it says we have one cube-shaped container that has an edge length 2 centimeters longer than the edge of a second cube. And we have a picture of this. The volume of the larger cube is 729 cubic centimeters. When the larger cube empties into the smaller cube, how much water will spill? All right, so they talk about the edge of the cube. So I'm going to say the first cube, edge. I'm just going to call it x. Okay? So then my second cube edge, it tells me is 2 centimeters longer than the first one. Okay, so I could say x plus 2. Now volume of a cube, okay? Since a cube all the sides are the same, then remember volume is length times width times height. So the volume of my first cube is going to be x cubed. Okay? So the volume of my second cubed is going to be x plus 2 quantity cubed. But they told me that the larger cube, which was my second cube, the volume is 729. So x plus 2 quantity cubed equals 729. I want to solve that because I need to find out what the volume of the first cube, right, with just the x is equal to. So I need to find out what my x is. So in order to get x plus 2 quantity cubed alone, I need to cube both sides. So then I get x plus 2 equals the cubed root of 729. Well, the cubed root of 729 is 9. So x plus 2. And again, I can do that by factor tree. And then I have to have 3 things that are alike to come out. Or I can just ask my calculator for the cubed root of 729. And then subtract 2, and I get x is equal to 6. Sorry. X is equal to 7. I can't subtract today, apparently. So x is equal to 7. All right, so the edge of the cube, okay, the smaller cube, was 7. So the volume of the smaller cube is going to be 7 cubed, which is 343 cubic centimeters. So how much water spills? So H2O spill. The volume of the larger cube, 729, minus the volume of the smaller cube, 343, right? The difference between those is going to tell me how much water was spilled. So when I find the difference between those, it's 386. These were centimeters cubed, so cubic centimeters of water spills. So 386 cubic centimeter of water that spills out. Let's try another one of those. So the next one cube has an edge length 3 centimeters shorter than the edge length of the second cube. The volume of the smaller cube is 200 cubic centimeters. What is the volume of the larger cube? So let's just do, again, first cube, edge, we'll call X. Second cube edge, it's 3 centimeters shorter, so that's going to be X minus 3. This time they gave me the volume of the smaller cube, so that's this one. So the volume, X minus 3 quantity cubed equals 200. Let's solve this. Take the cube root of both sides, so X minus 3 equals the cube root of 200. The cube root of 200, that is not a nice whole number, so I get X minus 3 is equal to approximately 5.8480. Add 3, so I get X equals approximately 8.8480. So now I want the volume of the larger cube. So the volume of that is going to be 8.8480 cubed. Plug that into our calculator, and we get that the volume is approximately 692.69 cubic centimeters. Okay. All right, the homework. For today, you're going to continue what you started yesterday. So again, it's in Envision, 5.1 on Envision. Whatever you did not get done yesterday, you're going to finish today. Now you have all the tools and resources you need. You've seen examples of everything. You know how to do all of the ones that have been assigned to you. And the entire assignment will be due tomorrow at the beginning of class.